Okay, welcome to Chapter 3, 3.3 and 3.4. 3.3, the shell model and chemical properties, and 3.4, electron configuration. Last time we colored our periodic table and we put these symbols on it. Remember that S, under S, that's a sphere, D, that's a cloverleaf, P, that's a sort of infinity sign. Remember, they're like balloons though, and they have skins, and F, we don't have to worry about. The colors I'll be referring to, make sure you have it by you so you can see what we're doing. So as we look at the first row on the periodic table, shell 1, that's known as shell 1, and it has one subshell, which is the yellow. That's all you get going across is the 1. The subshell designation is S. That's the only thing that's there is the S, which is yellow. And number of orbits in the subshell, we have 1. And the number of electrons that can be in that subshell are 2. Subshell designation I should put as 1s. And the maximum number of electrons in the shell are 2. So let's go down to the next row. The next row would be 2. So our subshell would be 2. The number of colors that we see going across on row 2 or that have a 2 in front of them are 2, the yellow and the red. The subshell designations of those two colors, the yellow is 2s and the red would be 2p. The number of orbits in each shell, the S always just has 1, and the P, remember we wrote equals 3 above, it has 3. Now each orbit can hold 2 electrons, so that means there is a total of 2 electrons in the S shell, but 2 times 3, which is 6, in the subshell. Now in electrons, in the whole shell, looking at the second shell, we'd add those two together and we get a total of 8 electrons totally in that shell. Now if we go down to the third level, let me pick another color here. The third level, we have 3 subshells. Now we have to look in the blue, but the blue has a 3 in front of it. So we have a yellow, a red, and a blue that have 3. So there's 3. The yellow is a 3s, the red is a 3p, and the blue is a 3d. So number of orbits, we've got 1 in the s, 3 in the p, and 5 in the d. So again, times that by 2 to find out how many electrons we can have in each shell, our orbit, and remember each orbit can hold 2, so the first one will hold 2, the second will hold 6, and 2 times 5 is 10 in the last one. If we add those all together, we get the total max for that shell as being 18. And the last one, I'm hoping I can squeeze in here, maybe not. We'll see, I was writing pretty big. It has going across level 4. If we look at level 4, we have yellow, blue, red, and green. So we have 4 shells. We have a 4s, a 4p, a 4d, and a 4f. And I ran out of room, almost. Okay, so we have 1 orbit in the S shell, 3 orbits in the P shell, 5 orbits in the D shell, and 7 orbits in the F shell. That means I can hold 2 electrons in the S, 6 electrons in the P, 10 electrons in the D, and 14 in the F, for a total of 32 electrons in the 4th level. And we could keep going. Now we only know up to F, so we don't know if there's a G or an H or a different shell, so that is the max that we would have right now is the F shell, which is 32 in each of these. Okay, when we talk about valence electrons, and these are going to be important electrons, these electrons right here are what we find in the S, which is the yellow area on the periodic table, and the P, which is the red area on the periodic table. And just going across on that row, will give us the valence electrons, which are the outermost, the highest energy. Now let's look on page 74 of your book. It has a table 3.2 that we're going to look at. Also have next to your color periodic table so you can sort of follow and see how it fits into what we've added to it, so you can sort of see what's going on. Okay, so we're looking at your table in your book and we're looking at what's here. So if we look at hydrogen, hydrogen is number 1 on the periodic table, and it has 1 electron in the S shell. You see that? And it is in level 1. So level 1, and it's got 1 in the S shell. If we go down to helium, helium is number 2. We're still on that first shell, and now we're still in the S, but now we have 2 in that S. Can you see that? If we go down to lithium, which is number 3, we now go to the next row. So we still have 1 S and we have 2 in there, but now we go down to the second row and we're in the S and we have 1. Can you see that? And then we go down to, let's skip a couple. Let's go down to neon. Neon is number 10. And so I'm going to fill everything up till I get there. So you can see from the table in your book, on the first shell, I've got 2. In the second shell, I have 8. You see that? So I'm counting across 1, 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. Then I go down, and I'm now in the third shell. So instead of filling that second shell up to its maximum, or it is up to its maximum, now if I keep going down, I'm going to start adding to the third row. Can you see that? I'm going to start adding to the third row. But I only get up to 8 on the third row, like as in, let's go down to argon. Argon's going to have 2 in the first row, 8 in the second row, 8 in the third row. When I hit potassium, then I go 2 in the first row, 8 in the second row, 8 in the third row, and 1 on the fourth row. Now the reason is that 4S right here, this group right here, has a lower energy, I guess I should do it in red, has a lower energy than the 3D. So I'm going to fill that up first before I fill up the 3D. Alright, hopefully that makes a little bit of sense to you. Okay, so let's take some that we have got here and sort of figure out how, what valence shell they would be in, what the N value is, and the number of electrons in that valence shell for the following elements. So let's take and do silver. So we've got silver. And silver is number 47. So let's figure out where all those 47 are. Let's say first shell, second shell, third shell, fourth shell, fifth shell is what we're going to need. So in the first shell, how many electrons does silver have? Well, it has 2, right? In the second shell going across on this row now, because we've already finished that one, we have a total of 8. Now in the third row, we've got to count this and this. So we do have a total of 18 here. On the fourth row, now we're counting here and here and here. So we're one away from 18, so that would be 17. And on the fifth row, which is right here, because we had to put every electron in to get up to silver, we have 2. So this would be where the allotment of silvers would be. Now notice I used, in the fifth level, I used 2 in a different color. That's because those right there are my valence electrons. They're my outermost electrons that have the highest energy. So let's do another one. Let's erase this up here and do another one that we can see where we're going. So let's take and do, oh, let's do one down here. PM, promethium. Okay, promethium is PM, and it is number 61. So it is right here. Now, we need to get every electron so that it will add up like this did to 47 to 61. So we're going to go, and we'll actually have one more level, which is 6. So I'm going to put that there, because right now this one had nothing in the 6. And we're going to start at the top. We have 2 in the first row. Okay, so I'm going to sort of arrow the rows as we do them. The second row can only have 8, and it does. And the third row takes in here and here and up here. And that's it. And it can hold 18, and it's got its max. And then I go to the fourth row, which is here and here and here and 5 more. So 18 plus 5 will give me a total of 23. Then I go to the fifth row, and we're going to do that one in red, and we got 5, and we won't have got to this 5 because we didn't come back up. It's before that starts with 71, and we're only at 61, so it won't count the D, but it will count the P. So I'm going to have a total of 8 in the 5. And then I still need to count these 2 on the 6th row for S right here. So I'm going to have 2 out in the 6th row. Now if we add this all up, it should end up being 61. Now if we look at the end value for silver and for PM, in other words, where do they end? What do we find? Where are they found? I'm going to take and, whoa, I can't erase that. Okay. Well, look at where they're found. PM is 61, and it is found in the 4th level of the F. So its N equals 4. For silver, it's found in the 4th level of the D. So its N level is also 4. N level is just that row number it's found on. Okay, that's a shell number. Okay, we'll see y'all in class.